Hello everyone, it's the 8th of October, which means it's time for the 8th October Leetcode challenge, starting at the beginning of week 2. So let's get straight into it. It's binary search. Binary search is actually a very useful algorithm to know, and it's actually an algorithm that we often use without thinking about it. Like, for example, when trying to find the page in a book. So let's say I have a book and I want to go to page 54. So I can just do this, and it's actually not gonna be bad. I can just list them all until I get to 54, since I have some intuition where 54 is gonna be. So there we go, found it. But for a computer, that basically means like 54 operations. My book has about 376 pages, I mean exactly that many, and if I was to use binary search to find it, let's just count how many operations that would take. So I'm gonna open the book somewhere in the middle, and in the middle I'm on page 184 right now. So what I'm gonna do is basically I'm gonna say, well, 54 is less than 184, so I can just discard everything bigger than 184. Why can I do that? Well, because I'm searching in a sorted array. Like, my book has its pages sorted. Like, every time a page is a smaller number than another page, then it will be before that. So, I mean, it's obviously important here to say that this algorithm only works in sorted collections and does not work at all in random lists or random collections. But yeah, let's go back to our example. So I'm on page 184. So I can literally drop half of the pages and then just look at the other half. So here, again, I'm just gonna look in the middle. I should be somewhere around 80, around 90, but I guess I got to 84. That's my middle. So 84 is still, come on camera. Can you do it? You can do it. Yeah. 84 is still bigger than 54, so I can just, again, drop half of the half, and I have just a quarter of them. And again, I'm gonna look at half of this, so 1/8. And I'm on page 30. So now, what do we do? Well, 30 is smaller than 54. This is my third step, so I'm dropping the first half. I have just this very tiny bit of pages here. And I'm gonna look in the middle. It's not gonna be really the middle. I mean, I'm cheating a little bit, but I got to, I can, if I'm lucky, get to 54 here on the fourth step. I mean, obviously, this is not very scientific, what I just did, but it took 4 operations, and it wouldn't take many more, even if I was doing it exactly correct. So these 4, 5, 6, whatever operations, it's like so much faster than the 54 I had to do when I was trying to find the page like that. And this might not be the best example, but I think it's pretty good for illustrating the problem. And yeah, I don't think there is much more to talk about it. I might show some examples while I'm solving it. And I'm definitely going to point here that I have solved this problem before, like probably before years for sure, like not recently. But it's a problem that I always do an off by one mistake. So let's see how this take goes. So let's just get straight to the problem. I mean, again, I'm gonna read it. Given a sorted in ascending order integer array, so order is very important, that it's ascending, since if it's descending, then the only difference is that we're going to the left for smaller values. I mean, if it's ascending, we're going to the left for smaller values. If it's descending, then we're going to the left for bigger values. But this is important to keep in mind. We usually expect ascending order. So we have that ascending order of integers in an array. We have a target, and we have to find the target. We using binary search, obviously, because that would be very optimal. It's much faster than any other sort of search. And yeah, if we don't find it, we return -1. If we do find it, we return the index where it's present. So yeah, you may assume that all elements in nums are unique and will be in the range of up to 10,000, and the values are -9,000 to plus 9999, whatever. Yeah, let's get straight to it. Where is my Kotlin? Let's go, Kotlin. Number 8. I'll add it later. Yeah, keep in mind we have GitHub now. I'm gonna link the GitHub again underneath the video. So if you want to check out the code, you can just see it there, like what we're coding here right now. I'm gonna take the boilerplate, and yeah, let's get straight to it. So we can solve it using recursion, or we can solve it using an iterative approach. In general, I highly prefer doing the iterative approach whenever possible. Like, I only do recursion if it's much easier to do, and usually not in production. Like recursion in production, I only use when I'm pretty sure that there are not gonna be that many cases, since obviously recursion can lead to a stack overflow, and that's much harder to do without recursion. But yeah, let's not splice too much off topic. So what do I need to do? I'm gonna give a few examples. We do have some examples here. But yeah, let's say we have this. I'm just gonna copy the array, and we're looking for 9. So I'm gonna pick a middle point. What is my middle point? Well, I have 1, 2, 3, 4, 5, 6. So it's either the 3 or the 5. Regardless which one I choose, let's say I choose a 3. My middle point is smaller than a 9. What do I do now? Well, I know that this part of the array is not the answer. This means that the right part of the array is my answer. So now I have to start from the 5, and I'm looking between 5 and 12 inclusive. So what is between 5 and 12? Well, it's the 9. So now I have found the 9 if that's what I'm looking for. And in 2 steps, I'll tell you that the index of 9 is like whatever this index is, 0, 1, 2, 3, 4. So yeah, there is one very tricky part that I'm gonna mention when we are solving it. But how do we start? Well, let's say we have a starting. We're starting from somewhere. Where are we starting from? Well, from 0, since this is the 0th element. I guess, do we know how many are the elements? N is the number of elements. It's between 1 and 10,000. So we always have at least 1 element. If we had 0 elements, I guess it would have been fine. But I could have just done some check earlier. Anyway, let's say we also have start and an end. The end is nums.last index. So this is the last index of the array. Or if you're using another language, it would be just the length of the array minus 1. So this is my inclusive range. So this is the start, this is the end. And now I'm gonna say while the start is less than or equal to the end. This is important, let's keep it in mind. What I wanna do is I'm gonna say midpoint equals to end minus start divided by 2. So on first glance, this looks very weird. Why am I doing it? Why am I saying 6 minus 0? Like it's 6 anyway. Why does it matter? Well, it matters for the second case here, because when we are starting from index 0, 1, 2, actually from index 3, then if we forget to do our calculation, we would be starting again from the 0. So basically what I'm saying is my midpoint is not the end minus the very first index of the array, but it's the end that I'm starting from, which here is the end of the array, minus the start where I'm starting from. So in this case, in my second step, I'm gonna say 0, 1, 2, 3, 4, 5. So 5 minus 3. 5 minus 3 is 2. So I'm taking the midpoint of 2, which is 1. This is very important distinction, because if I forget to do that, then my midpoint is gonna be what? I'm gonna say again 5 minus 0. So I'm gonna say midpoint is 2. So where is gonna be my midpoint? It's gonna be forever here. And one more thing that I need to not forget is that since I'm starting from index 0, 1, 2, 3, in order to move it one place to the right, I not only need the midpoint, but I need to add the midpoint to the currently starting index. So if I'm starting from here, from index 2, and my midpoint is 1, the difference between my endpoint and midpoint is 1, then in order to get to the middle of these 2 points, I need to add it to my starting point. So this is basically how it's gonna look like. And this is the part where I usually get it wrong. But I had some practice today, so I guess I know it. So yeah, this is my midpoint. This is very important. And starting from the midpoint, the rest should be pretty trivial. So if the current element, so num's midpoint, I guess I'm gonna extract it also. So mid num is that. If mid num equals to target, so if we have found a target, well, we just return it. Or return the index, so midpoint. We return the index, since this is what we need to return from this question. And now if mid num is less than target, what does this mean? This means that, let's say we are here, mid num is 3, and we're looking for 1. Well, 1 is, no wait, we're looking for mid num is less than target, so it's this case exactly. So we're looking at number 3, and our target is 9, which is bigger than the mid number. So this means that we need to move the start index from 0th position to the current mid position. But not only to the current mid position, because we're actually guaranteed that the current mid position is not the answer. We know that this is not the answer because we just checked. So we can actually move it 1 to the right. This means that our start is equal to the current midpoint plus 1, since we're moving it 1 to the right. So we're starting from 5 the next time. Else, so we covered equals, we covered less than. This is always bigger than, for sure. So let's say we're checking another example. So the same values, but we're looking for 0. We're looking for 0. Then again, midpoint is, let's say, is our 3. I have no idea why I'm using the percentage here, but it looks nice, so I'm gonna keep using it. So now we have the mid number 3, which is bigger than the 0 we're looking for. What does this mean? Well, it means that we need to keep the starting point, so we keep 0 of index as a starting point. So this is incorrect actually, like -1 is before the 0, obviously. Yeah, I must have copied it incorrectly. So yeah, let's say that we're keeping the 0 of index as a starting point, but we need to move the end index to our current midpoint -1. Why -1? Well, because we are again guaranteed that this is not the answer. We just checked, so we can start to 1 to the left. And also it's gonna help us with the end condition here. So let's say end equals to midpoint -1. And I think that should be the answer. Like, this should be enough for answering the question. And if we don't find anything, we're just gonna default to return -1. All right, so let's just sanity check it by using the examples given here. So search int array of this and target 9, and we wanna print out what happens. Whoops, let's print out what happens. Oh, 4, 0, 1, 2, 3, 4. This is expected. If we're looking for -1, I'm gonna just check the edge values, because there I can have like an off by 1 exception. I meant to write 12 here, but 10 is fine. 10 is also like something that doesn't exist. So I think it's okay. Yeah, it's covering the edge cases as well. Now let's go ahead and submit it to Leetcode. Run code. Okay. All right. Passed the test cases. Amazing. Let's see how other people solved it. My favorite part. One-liner. I hate those one-liners. This is not a one-liner. Oh, he has a one-liner here. This is terrible. I don't even want to read the one-liners. Standard binary search Python. I guess they're doing basically the same thing, but yeah, pretty much the same thing. Ruby. Again, the same. There aren't like any fancy ways. We can also do it using recursion. Use this one using recursion. Search ints. What the f... Okay, whatever. Just in case you don't know. Arrays.binary search. Fair enough. I actually didn't know that there are arrays.binary search. That's pretty nice. int. Searches a range of the specific array of longs for the, yeah, whatever. Well, that's pretty neat. Anyway, I'm glad that this task was a little bit easier so that I got to do some more explanation. If you're watching this and you enjoyed it, I'd love if you can like either leave a thumbs up or say something in the comments. Otherwise, Victor from 1 or 2 years from now will get to watch this at some point and have fun or not have fun. Doesn't matter. Anyway, thank you for watching. See you tomorrow.